Hello friends, today's topic is time complexity and I have covered all the major questions so that you can do any type of questions based on the understanding of these. Okay, so let's understand each one of them. Okay, so the first one, so in this question we are calculating a sum in a recursive form. So whenever we do anything in recursive form, there is a stack. So this is basically a space, this stack takes space. Okay, so let's say n here is 5. So it will call to the stack when it reaches here. It will call sum of 4. Okay, so it will go like this. So it will call sum of 4. Now sum of 4 will call sum of 3. It will call sum of 2 and then sum of 1 and then finally sum of 0. Then when it reaches sum of 0, since n is exactly equal to 0, it will return 0 and it will return 0 to this one. So it returns 0. Then it will return n plus sum of n minus 1, that is 1 plus 0. So it will return 1. Then it will return similarly like this, 1 plus 2 3, and then it will return 3 plus 3 6, and then finally it will return us 10. 5 called it basically. So 5 called 4, then 3, then 2, then 1. So it 6 plus 4 return 10, and 10 plus 5 is finally 15, which is returned to the main answer. Okay, so when you calculate this, this is the result of 1 2 3 4 5. So as you can see, this stack is created behind the scenes. So this stack is of size n. So the space complexity is n, and if we can see, we are not using a loop here, for loop, but we are calling this function 5 times. So basically 5 things are happening. Whenever we are calling this function sum of n minus 1, so we are doing one step. So this is 1, then 2, then 3, then 4, then 5. So basically it is time complexity is on. Now whenever so there is a basic rule, whenever there is some constant with it, like n plus 5 or 2n. So we remove the constant. So n plus 5 becomes n and 2n becomes n. So in the second example, we are calling this loop and we are traversing through an, let's say, an array. Okay. So array A, and then we are traversing through an array B. Okay, and here we are doing something like some operations. Okay, so whichever operation it is, it doesn't matter. Okay, but it should be in constant time. Okay, constant time operations. Here we are doing some constant time operation. Okay, like count plus plus, or assigning value to the array, or getting value from the array. Okay, so what will be the time complexity of this? We are traversing through this array. So basically a dot size, the size of the array A, and then plus size of the array B. But let's say we are doing for loop inside another for loop. So basically like in a matrix. So let's understand it in a better way. Let's say we have an array A and an array B. Okay. So basically the time complexity we are saying is a dot the size of the array A plus size of the array B. Let's say the size of array is n and the size of array B is also n. Okay. So basically same. So basically n plus n, that is equal to 2n, and then we can remove that constant and we can say n. Okay, but when we don't know the size of the array, let's say this size is 500, we don't know the array basically, size of the array. The size of array is y and x, so we can't assume anything, and we have to say it. The time complexity would be the size of array A plus array B, that is y plus x. Okay. Now, when we are traversing through array, basically loop inside loop, you can see we do this while traversing through a matrix. Okay, so when we traverse through a matrix, we go from every row and we go to every column. Okay, so if you can see, this is a 4 cross 4 matrix and it has basically uh, 16 values. So we are traversing through each element. Okay, so this is n square, 4 cross 4. So similarly here, if we know the size, it would be n square. But since we don't know the size here, let's say this is an array A, we don't know the size, then we have to mention A dot size into B dot size, A ka size into B ka size. Okay, so I think this was very basics, these three. Okay, then let's discuss this fifth question. So for fifth question, I will tell you a trick that will help you to do many questions and it is very important. So when we are when we are doing recursion, so we discussed the recursion question above also, the first one. So here the time complexity was n only because we are calling the sum function inside sum function only one time. Okay, but whenever we are calling it more than one time. Okay, so here we are calling Fibonacci function only, but two times. So in this case, the formula is branch की power depth. Basically, this one, branches की power depth. So here we are calling this function two times, and we are and we are going it basically n times. Okay, so it is 2 की power n. So let's say if we were calling a function here three times, like plus Fibonacci n minus 3, then it would be 3 ki power n. But as you can see, this will be only applicable if we are calling it more than one time, because here also we are calling and we can't say 1 ki power n because that would be 1 only. So this would not work like everywhere. We have to see some conditions and move forward. But for most cases, it would be branches power basically for n greater than equal to 2, and we have to check some conditions that we can see if we will be able to see in this video. So it will be 2 ki power n. There is a graph question, the the snakes and ladder question. So when we play Ludo or any other board game, and the dice can give us six values, 1 2 1 2 6. So when we solve it through DP, basically we call the function that is solving six times for each value. So there the answer is 6 ki power n. Okay. So since you can see this time complexity is very large, also 2 ki power n is also very large. So we use DP. So I will not go into that, but you just have, but just know in the back of your mind that when like this the time complexity is getting very large, so we use dp to reduce the time complexity, and we can reduce the time complexity of this same problem to from 2 ki power n to n by using dp. Okay, so yeah, so let's move forward. So in this we are finding the prime, and here you can see the condition is a little different, not I less than n but I square less than n. So here we have also one trick. Here you can see that we have I square should be less than n. When we say that I is less than n and I is moving one step ahead, so we say the time complexity is n because it is moving n times. But here we can say that I square is less than n, so I is less than root n. So the time complexity would be root n. And this is a very similar question. We are so here you can see that sum is less than equal to a. Now some value is b. So you can say b is less than equal to a, and we will make it 1 here. So it would be a less than b. So that would be the time complexity of this question. So these are some tricks that you can use, but we have proper formulas to solve this time complexity, like Master's theorem, and there are many other theorems and formulas. Okay, but we are doing it manually. Okay, so we did see above that to find Fibonacci of a number, the time complexity was 2 to the power n. Now to find Fibonacci of n numbers. So the logical answer would be n into 2 to the power n. But here the answer stays 2 to the power n. So to understand this, you will have to draw a proper tree, and like it goes 2 to the power 1 plus 2 to the power 2 to 2 to the power n, and then when we calculate the Fibonacci of n numbers, it goes to n plus 1 and not to n into 2 to the power n. So it stays 2 to the power n only because we remove the constants. Okay, and yeah, so these two questions would be very important. Let's see, uh, to find the sum of all the nodes in a tree. So we do this. Okay, so as you know, the trees are basically we do it in a divide and section, and whenever there is divide and section like binary search, so the time complexity is n log n, because we are basically, like, let's say the array of size is n, we divide it by n by 2, n by 2, then they are further divided into, basically we are divide and conquer, n by 4, n by 4, and it goes on. So in trees, basically the depth is log n, and we are calling the sum function two times. So basically branches की power depth 2 की power log n, that is equal to n. So here the time complexity would be n. So you have to see it very carefully. Then let's see this question. Here we are traversing through the array, and we are so when we are doing I is equal to I divide by 2. So here basically we are dividing. Okay, so basically this one is log n, and this one is n. So it should be log n into n. So it should be n log n. Okay, but here is this, but we have this rule that log n into n, the time complexity would be n only. If it is n into log n, then the time complexity would be n log n. If this loop would be outside and this loop would be inside, then it would be n log n. But since it is in this way, so the answer is on. So I hope this video helped you, and please comment if you liked the video. Please give feedback and like the video. Thank you.